at good night. Today is September 15, Brazil, Puerto State. I'm David Okobi. I'm a CEO and founder from Orpea Quantum, a deep tech which is responsible to solve the coherence, quantum decoherence problem. Where we use, I'm a person who is responsible for phi waves theory. Phi waves, it means a symbiotic phase harmonic yielding, wave lines, and vibrational entangles, a stabilization, and this is a chromium. But today I will do a very different simulation. I will do a Starship simulation. Now my code is opening to you to see that, and now I will use a Google Voice to help you and conduce you once I explain. Once I and guide you why I use my mouse and my computer to show you how to do this simulation today. Is very important to me. I'm apologize for because I'm using the. I'm so sorry. I'm using someone that's in Portuguese, but you can use any AI to translate that. But do not forget, you cannot access my Simbiotic AI, the importations. Okay, but you can access all the code. Is very simple, and today I will do a different simulation, and let's start a Google Voice. She will help me on the simulation today. Thank you.
The grand proposal we're used to thinking of rockets as brute force machines, overcoming gravity with the power of their engines. But gravity is actually a field. What if we could harmonize with this field instead of fighting it? Our simulator is a proof of concept for a new era of space travel. It tests a theory called vibrational quantum gravity, where the ship's propulsion is controlled not by force but by resonance. The three pillars of simulation. Our simulator is composed of three interconnected entities that work in symbiosis. Like the organs of a living organism, the sensor, the EA_SPHY_guardian unit, what it is. This is the ship's sensory organ. It measures not the force of gravity, but the vibrational entropy of the gravitational field. It senses the tiny deformations and tensions in spacetime. What it does, the sensor translates these vibrations into quantum data, calculating the SPHY, phi, phasic field and generating feedback for the ship's brain. The brain, the Meissner_core unit, what it is. This is the ship's mind. It receives sensor feedback and processes it along with the system's entropy. The Meissner_core doesn't look for an error to correct, but rather a disharmony to harmonize. What it does, the brain calculates the system's coherence level and generates a boost. This boost isn't a command to increase thrust, but a value that tells the ship how well it is resonating with the universe. The engine, the Harpia Waves propulsion unit, what it is, the ship's engine. It's a propulsion system that not only generates thrust but also adjusts the SPHY, phi, phasic field through fuel combustion. What it does, the engine translates the brain's boost into a fuel burn rate. Instead of fighting gravity, it bounces field by field, adjusting thrust to ride the gravitational wave. If Meissner_core senses the ship is losing resonance, it adjusts the burn rate to restore resonance. The simulation result. The simulation doesn't measure success or failure, but harmony. The data the simulator generates, such as average coherence, percent, and coherence variance, show how well the ship maintains its resonance. If coherence remains high, It means the ship is using the entropy of the universe as its own fuel, moving with minimal resistance. The simulator is proof that the future of space travel lies not in building bigger engines, but in understanding the nature of the field that surrounds us. Finally, I'll wrap up here and let you watch the simulation now.
Now she finished. I will use a Python. I'm using Qiskit. My version is 2.1.1, and as you can see, let me use a pip show Qiskit. As you can see, now let's do an AI simulation. You saw my my main code. This is the number of qubits. Sorry, this is Portuguese, but I will do a English also. I will select 30 qubits. Total number to number frame to GHZ to simulating. I will start let's start a 1200. It's a good number, and the noise level is maximum 1. I will use 1.0. It's 100%, and the number of the processes is a multi-thread process. I will use only 4 because I'm a i5. My machine is a i5 machine. 10 generation, one of 24 gigabytes RAM, and now this is Starship Coherence control with AI, symbiotic AI. She is stabilizing the coherence, and we will have a printed coherence control levels on the end. This will take not too much time. I will not simulate a huge number today because once I use the OBS together with combined with my computer, this consumes a lot of my processor and my memory, and it takes too much time. Is a double time less, 2 times less speed to do simulation, and this AI consumes a lot of processes because she's simulating total a body with the my Starship a prototype. Is not a real Starship, but it is a prototype. And I think people what you see this simulation probably they are very investigated, and I will show you. Yes, I did a good simulation. 100,020 frames, spent 1 hour 57 minutes. You cannot see the graphic, but it will put the available for you once they did. And now I will do once more using a little simulator board to increase it a 30 qubits and use more 3,600 frames. And I use it. Or you put 1.0 is 100%, and total 4 cores. Okay, it's again. You take more, probably 5 minutes. And this night I will not go pretty much longer because I did a good simulation. 120 to 12,000 frames, and this is available to download directly on my Google Drive, up here Quantum Google Drive. And then I have a good interesting thing to tell you. I designed this because once I was a kid, a little young boy. I have on 80 years old. All the time I was thinking how to build a spaceship. Many times I play tent. It's a similar. It's a similar a toy with a Lego. A but when I was a young kid, I prefer tent because it's more flexible to design to play anything. I was thinking how to build this technology, and then all the time I love to think computers and technology like AI, which will be responsible to solve this solution with harmony and resonance technology to control a not only the proportional the propulsion of the starship propulsion and a resonance to keeps the body the starship body is a intact very uh, a very good. I believe you can do the same process with submarines. Could be that, but and I will not enter into too much detail because this is physicists control. Resonance is very complex and will take too much time to explain this. But I put my paperwork to download directly on my LinkedIn. It is available to download. I will do download it directly on the YouTube also. Is available to download in X. It's available to download also in my Facebook. Is also Tech Art a XIV is available also. Is a preprint. I know many persons who love the Starship will love these processes because they will save a lot fuel. It save a lot. It save a lot fuel, not only fuel and material also. Maybe turn possible to fly a fly more less than 240 days. I have no idea. I will do with the simulation next. This is a good application of the sphy wave theory on using a quantum computer to control a starships by resonance. The same physical processes could be used to control lasers and could be used to a X-rays and many other technologies. I can use it also. Earthquakes detect earthquakes, tsunamis, and also could be tornadoes or any a hurricane, also tornadoes or hurricanes. It's almost finished. Once this finish, I will open the CSV for you online. This one to prove that I'm simulating in the real. And the more important thing, we have to see the coherence is index, and as you can see, look at that coherence and variance and is reducing, and the more important, the coherence index increase. Okay, let's check and see what's happening. No, this is the CSV. Let's check that. No. Okay, this is the file. Each frame has been signaled by one using a SHA. Coherence and results. Okay, signature, sensor, frame, result. As you can see that. Thank you for watching, and on this night I will finish this video, and I'm very grateful for everyone which is coming here and watching my videos, and I will share this on this night. Thank you. My name is David Okubi. I'm talking from Pure Quantum Laboratory, and I see you again next time.